Today we're going to be taking a look at the second part of the 2D toolpaths for newbies. Now don't worry if you haven't seen the first part. I'm basically going to go through it really slowly anyway. It's just a little bit more advanced than the first part. We're going to take a look at some different options, a bit of V-bit carving for instance, rather than in the first part it was just cutting out area clearance, creating pockets and drilling. Okay, so the first part of the webinar, which was about a month or so ago, I believe that you can get that on YouTube if you do want to see it again. Yeah, just watch that whenever you like. It's pretty straightforward, easy to follow along. I'm also going to be creating a recording of this webinar, which will also go live, so you can take a look at this afterwards as well, just if there's something that you don't understand. Okay, so in the first part, I created this chopping board in ArtrCAM standard. Okay, now if I take a look on the right hand side under Toolpaths, you can see that I've got 4 toolpaths. So what I'm going to do is just simulate these, just so you've got an idea of what I actually created. So if I right click, I'll do this with the control bar so you can actually see. So drilling toolpath, area clearance, so this is creating the name or the initials. Okay, a profile, so this is creating the groove around the edge, and then finally the cutout pass. Okay, so if I go to simulation, I can just delete the waste material. And I can also add a depth color if I want to, just so you can see the finished piece. Okay, so that's basically exactly what I've done in the first part of the webinar. So what we're going to do today is, I don't really want the initials to be an area clearance. I don't want it to be a pocket. I want them to look a little bit nicer, and I can do that by using V-bit carving. It's really, really easy to do, and it gives a much nicer finish when you want to create, let's say for instance, letters like these. And then I'm going to show you various ways or various techniques that you can add to the cutout pass, because sometimes you may not just want to cut the part out. There may be certain times that you need to basically feed the tool in before you actually start cutting. So these are called lead moves. You can also add bridges, but I'll come to that a little later. The first thing is to sort out this text. Okay, so if I zoom in and I'm going to delete the simulation, and let's turn on the vectors. So here you can see I've got this LA, which is basically my initials. Okay, so what I'm going to do is select the area clearance, which is that particular toolpath. So if I just simulate that, I can just check. So there you can see it is. Let's go to the simulation. I'm just going to turn off the material, just so it's the original default simulation. So let's delete that, and I'm also going to delete the area clearance. Now you do that by right clicking on it and then just coming down to delete. Okay, and then that just deletes the area clearance. Okay, so to do this, what you need to do is select Toolpaths, and then under 2D Toolpaths, that's all that we're dealing with in these webinars. I'm going to create a V-bit carving toolpath. So if I select that, and I'm going to select the text like so, and what I need to do is select the carving tool. So if I click select and I come down to V carving, and I'm just going to choose, let's say, a 32mm 90-degree V bit. Okay, so this V will basically go down in between those vectors, and it will go down as deep as it can, okay, to create the effect. and then it will, when it gets to the corners, it will sort of roll out of the corners and it will give sort of a 3D effect. So if I click select, now one thing that's really good to get in the habit, one thing that's really good is to select refresh. Now what this does, it automatically calculates the deepest point where the tool can actually get into these vectors. So if I select refresh, you can see that the maximum depth is 2.6. Now I know that my material for this, if I take a look down the bottom, is 15 millimeters. So I know that it's not going to cut through the base into the bed of my machine. Okay, so it's just a good practice to just select refresh. Now, sometimes that refresh also gives you basically a warning message. So let's say this A, the island was there. So I've got all of these vectors overlapping each other. So if I try to do it now, it gives me an error message saying that vector intersections was found. And I need to basically sort that out before it will actually machine it, because it don't know where to go in between. Okay, so let's just undo that. Select refresh again. You can see that it's 2.6. Now, the maximum width is only 5 millimeters. If I was doing something that was really, really big, then obviously I would want to use a roughing tool. So you can actually rough this out and take all of the material out of the way, just leaving enough on for the V-bit at the end, because it's not good practice really to use the V-bit to blast away lots of material. V-bits cost quite a lot of money. You don't want to basically wear them by getting rid of all this material. Okay, so good idea to use a roughing tool if it's going to be quite a large bit of V-bit carving. So that's basically all that you need to do. Okay, you can limit the tool to a maximum depth if you want to. So let's say I only wanted that to go down to, I don't know, let's say 2 millimeters. I can turn on the maximum depth and change it to 2 millimeters. But what this will do, it will leave a flat at the bottom rather than a straight point. Okay, so if you wanted to, you could turn that on. Okay, so I already have my material set up. I can do that again if you missed the first webinar. Click Setup, just type in the thickness there, 15. I want this to be at the top of the Z. Select OK, and then just select Calculate Now. Now if I rotate around, just zoom in, and let's turn off these toolpaths here. You can see that I've got this red toolpath and it's sort of going 3D. So what I can do is let's simulate this and you can see exactly what this looks like. Okay, so that's created this sort of 3D effect with the V-bit carving. Okay, and I think it looks a lot nicer than rather than just doing a pocket. Okay, so that's how I'm going to do that. Now you can see that the V-bit carving is actually below this profile 1. Now if I zoom out and let's simulate this profile 1, that's the cutout. Okay, now I don't want to be doing the V-bit carving after the cutout. I need it to be before. So if I want it to be before, all that I need to do is just drag and drop where I want it to go. So let's move it, let's say to the very top. Okay, so that's at the very top of the toolpath list. And if I want to, because that's a bit confusing, profile and profile 1, I'm not too sure what's what there, I can rename this by right clicking, selecting rename, and I'm just going to call that cutout. Okay, so that's all that you need to do. So let's delete the simulation. Let's turn on the vectors again. And we're going to take a look at actually cutting the part out. Okay, so I've got a basic cutout, as you can see here. Let's simulate it. So it's just a basic cutout. Okay, now what if, let's say for instance, I was clamping on the edges here and I cut the part out and it wasn't being clamped anymore and it flew out the machine. Okay, now sometimes you put double-sided tape on the back of it to stop that happening, but if I want it to basically stay in the material, I'll show you how you can do that. You can do that by using what we call bridges in the software, also called tabs. Basically they leave a little bit of material on so it doesn't basically disconnect from the original piece of material. Now when you take it off the machine, obviously you need to just break these tabs off, do a little bit of sanding on them, but it's a lot safer. Also, when you actually feed into the material, sometimes you don't want the tool to just come straight down on the actual vector. Sometimes it can gouge or deflect into the material, and then you've got a small gouge. It's a lot nicer to actually start outside of the vector and then feed into it, so the tool can get up to speed as well. And sometimes when the tool actually comes in, maybe you're not cutting, let's say for instance you're cutting, I don't know, acrylic or plastic. When that tool actually plunges in, sometimes it may catch fire or start burning the plastic. So you want that to start outside and then come in. Okay, so I'll show you how you can do all of this. So let's delete the simulation, turn on the vectors, and then I'm going to right click on the cutout and select edit. So I'm not going to create a completely new toolpath for this. I'm just going to edit it. Let me just zoom out just so you can see this. Okay, so the first thing that I'm going to do is basically just calculate this so you can actually see it. Let's just turn it on. Okay, so let me zoom in here. So what you can see here is I've got the vector at the top in pink, and then below that I've got two red toolpath lines. Okay, so this is going to go around that vector twice using this 12mm end mill. Okay, now the step down is 12mm. So it's going to step down 12mm and then do the rest basically. So this is two cuts. Now, maybe I don't want to do that. I want to basically the final cut, which is going to cut through the material. Maybe I want it to just be quite small. You can do that by selecting the final pass thickness. So if I change that to say 1mm, it will do a last cut that's 1mm above the base. So if I calculate that, you can see that I've got the two cuts and then I've got a final cut. Okay, so it's leaving that 1mm. Okay, so this, maybe you might want to do that rather than having a really large cut when it cuts out. Okay, so I'm just going to turn that off for the moment. I don't really need that. And what I want to do is take a look at these three options here. So we've got add lead in, out moves, add ramping moves, and add bridges. Okay, so the first one is add lead in, out moves. So let's turn that on. And that opens up quite a few options. Okay, now at the moment it's linear. Now I'm probably best just doing this and then you can actually see it. Okay, so distance, I don't know, let's say 25mm. Okay, and then calculate now. Okay, now you can see what's happened here. Just take a plan view, is that it's added this here. So what's actually happening is that it's feeding in and then creating the cut and then feeding out. So if we just simulate this, okay, so what's happening is that it's coming in, cutting, and then coming out. Now, the benefit of this is that it gets up to speed by the time that it actually hits the vector that you want to cut. okay, and it's not plunging in here. So you're going to get a perfect edge rather than the tool deflecting, and maybe you get a little bit of a gouge in there. Okay, so that's the linear. Now you can see that it's automatically put this here. Now, what if I don't want that? Let's turn off the simulation again. What if I don't actually want that to be basically there? What I can do is turn off automatic positioning, calculate again. Now it helps if you actually select the vector, calculate again. Now you can see that that's done that at the very top. Now the reason that it's done that there is because of this green point here. Now this green point is the start point. So it's creating the lead on the start point. Now if you ever wanted to move this and change the start point, it's really, really easy to do. I'll show you how to do it. So you select the vector, go into node editing, which is on the left at the top here. Shortcut for that is N on the keyboard. And then if you just find a node, you can add a node yourself wherever you want. It's entirely up to you. Let's say that I want it to start on this side at this node. What I can do is right click on that and then select P on the keyboard, or just select start node. And that changes the start node to here. Okay, so that's quite useful for when you're cutting anyway, not just creating the leads. So I can exit the node editing, and now if I calculate this again, the lead should be at the bottom. So you can see the lead in, lead out is at the bottom. So if I just simulate this so you can see. Okay, so that's how you create just a linear lead in and lead out, and how you can position them. So let's delete that simulation. And let's take a look at a circular arc. So maybe you don't want it to go just basically linear, you just want it to basically sort of ramp in on a circle. So what you can do is change, let's do that at 25 millimeters also, calculate, and you can see that you've got this circular lead in. So if I simulate that, you can see what this one does. Okay, so it gives a nice smooth motion rather than basically coming to a point and then going off at an angle. Okay, so this gives a really nice smooth motion. Okay, so let's delete that simulation. Again, turn on the vectors, and let's add some ramping moves to this also. Okay, now ramping moves control how the tool plunges into the material. Okay, so let me rotate this around so you can actually see this. Okay, so you got spiral, so it will spiral down into the material. Zigzag or smooth. Most of the time I just use zigzag, to be completely honest with you. Click calculate, and you can see, if I just rotate around, that I've got these colours, or sorry, I've got these zigzags in this cyan colour. Okay, now that's basically how the tool is plunging into the material. Okay, now this is good because obviously stops wear on the tool, also stops burning. So what you can do is change the angle of this. Let's say I'll change the angle, let's say 30, and you can see that it's going down much steeper. And you can also change the length of that. Maybe I want it to be 20, and you can see that it's a lot wider. Okay, so you can control how your tool goes into the material when it's plunging as well. So it saves you wearing your cutter. Okay, now onto the last option, which is bridges. So if I take a plan view and let's select add bridges, and you can see that Basically, I'm going to use the default value, which is 4, and it's constant number. The length, let's say I want these to be 10 millimeters wide. Thickness, let's say 5 millimeters. You can do 3D bridges or 2D bridges. Now, 2D bridges will just be basically just straight 10 by 5 millimeters. The 3D ones, they actually come up to a point, so they're much easier to break off. Okay, so at the very highest point, they'll be 10 millimeters in length. Sorry, they'll be 5 millimeters in thickness. Okay, so it's much easier to break them off and to sort them out. Okay, so when you're happy with that, select Add. And it adds 4 bridges that you can see here. Okay, now if you want to change them or you want to edit them, just select Edit Bridges, and then that takes you into a new sort of mode, and you've got blue dots and white dots on these nodes or these bridges. So what you can do is hover over the blue dot and just move it around to wherever you like. Okay, so if I wanted to, let's say, move that one to there, I can do that. And if I want to make it larger, just select the white, okay, and just drag it out. So let's say that I want that one to be a bit larger. That one, let's move that round, let's say round to there. Okay, so that's how you can edit the bridges. Now what these do, they'll keep the part in the material, so it saves it flying off the machine. So let's exit that, and then when I'm happy with that, I can select Calculate Now. Now the good thing about these bridges is that they're assigned to the actual line, to the vector. So if I were to copy this, it would copy the bridges also. So if I were doing lots and lots of these, and I wanted to say nest them, I could nest them all together and it would keep all of the bridges in place. Okay, so it saves a lot of time doing that. So if I select Calculate Now, you can see that it's created these markers here. And what that's doing, it's actually lifting up. So if I rotate around, let's take a look here, you can see that the toolpath is coming around and then lifting up to create that bridge to keep it in the material. Okay, so let me just zoom out and I'm going to simulate this. So let's simulate that, just that cutout for the time being. So you can see the lead in and lead out. And you can also see that it's left this material here. Now, obviously this bridge here is not doing anything because it's just cut out the edge. So that's my fault. I shouldn't have put it there. Okay, so that's the good thing about the simulation. You can actually see it before you actually machine it. So I'll probably want to go back into that and then move that bridge to somewhere else where it will actually be holding on the original material. Okay, so let's simulate all of the other tools. I can just delete that, and then let's just simulate everything all together, and we can see what it looks like. Okay, so that's the finished chopping board. Okay, now that was a few more of the more advanced sort of options with the 2D toolpaths. Some things that you may never even use. You may use the bridges, for instance. If you want to save this and send it to your CNC, I'll just show you how you can do that, just in case you didn't watch the first webinar. You can do that by selecting here to save toolpaths. That opens up a dialog box which has all of the toolpaths on the right hand side here, and what you can do is save the toolpaths to separate files. So if you want each of these to be separate, rather than having to do each one, you can just save toolpaths to separate files, and it does one for each anyway. You can also append the toolpath details to the file name, so it puts all of this information within the file name. You probably want to add a home move at the end of the file, so when it finishes it goes back to the machine's 00 or home. Let's save it somewhere, so let's select browse and let's have a look on my desktop and let's save it in here. Let's call it, let's say part 2, and then probably the most important part of this is the machine file format. So if I select that, you can see all of these different CNC and laser machines. Now, your machine will probably be on this list. I'll take a look, see if it is on there. You can download the demo version or the free version. All of these post processors, what they are called, are included in the download. Most of the machines nowadays will accept just normal G code. So you want the G code ARCs. So let's select that. And what this does, it converts the information, the toolpaths from ArtrCAM into a format that your CNC machine will understand. Okay, and it will get cutting. So if I select save, that's all that you need to do. Cancel that. Let's take a look. Let's take a look in this folder. And you can see that I've got these 4 what we call tap files, which are just basically text. So I can just open that up and I can see that it's got G commands, which basically tell your CNC to turn on the spindle, etc. There's also coordinates that tell it where to go to actually machine that. Okay, so it's just a series of commands and numbers. Okay, and then stick that onto your CNC and away you go.